right, so what do we do with the urine once it's formed? Well, you know, it goes into your ureters. So it's going to go into the renal pelvis, into the ureters, and the ureters are going to carry the urine down into the bladder by peristalsis. So there are peristaltic contractions that cause the urine to move down into the bladder. That's why you can continue to form urine and lose it into the bladder when you're sleeping, or if you're in outer space, right? So it's peristaltic contractions that move the urine into the bladder. The bladder stores the urine. So rather than just constantly dribbling urine out as you're forming it, the bladder stores the urine so that you can hold on to it until it's an appropriate time to urinate. There are specialized stretch receptors in the wall of the bladder, and when you get somewhere between 200 to 300 mils of urine in the bladder, so about a cup, a little bit more, these stretch receptors are stimulated. They'll send an impulse to the spinal cord, and the impulse comes back, and it will cause relaxation of the internal sphincter. It will cause relaxation of the internal sphincter. So they're trying to show here the internal sphincter. The arrangement in the urethra, at the tip of the bladder, start of the bladder, is to have two different sphincters. An internal sphincter of smooth muscle that's proximal, and an external sphincter of skeletal muscle that's distal. We'll talk more about this on Wednesday. Don't forget, we have a quiz on Wednesday. On the urinary system, I want to go back just for a minute at when we were talking about the countercurrent multiplier. I wanted to say one more thing here. We talked about the fact that as humans, we are only able to concentrate our urine to 1,400 milliosmol. We don't produce pellets. As a consequence of that we could only concentrate our urine to 1,400 milliosmol, you will lose some urine each day. And the urine that you lose each day, no matter what, because, right, you can only concentrate it so high, has a name. We call it the obligatory water loss. And so it's the obligatory water loss, and it's about 400 milliliters of water. I didn't tell you this the other day, right? No. So it's a term that you run into, and those people that have lab, when we discuss the urine lab, we'll be talking about obligatory water loss. And
the urine?
Because we did that urine lab, when I give it back to you and we discuss it, we're going to talk about the obligatory. So you will lose about 400 mils of urine each day, and we call that the obligatory water loss. So even if you didn't drink any water all day long, you're still going to lose some urine because your kidneys can't form pellets, right? We don't produce pellets. All right, so we did all of that. We talked about the ureters, and we left off talking about the bladder. And so we learned that there are two sphincters at the bottom of the bladder. One's an internal sphincter of smooth muscle, and that's going to be proximal. They didn't do a very good job of showing it. And then there's an external sphincter that's distal, that's made of skeletal muscle. When those stretch receptors in the bladder are stimulated, they cause the smooth muscle internal sphincter to relax. If it's not an appropriate time to urinate, you keep your external sphincter contracted. Infants have not yet learned to control that external sphincter, and so whenever their bladder fills, they empty. Right? Okay. Your urethra, it's going to carry the urine out of the body. In males, the urethra is about 8 inches long because it passes through the penis. In females, it's only about 1.5 inches long. Some abnormalities of the urine.